Hello everybody. I'm Torsten, and if you don't understand what I'm saying, please put on your translation headset. But I don't see anybody needing one, which is really nice, because I prefer that you understand me directly. My name is Torsten Grote. I'm from Germany, and this is my second presentation at Fisl, and I'm really happy to be here. I have a lot of fun at that conference, and thank you very much for coming today to listen to my talk about Kolab, privacy retreat and collaboration software. So let me introduce the whole topic by showing you how the internet gradually developed in the recent years. Because normally the internet is like a whole networky kind of thing with nodes in the network that all have the same right, that are equal. But what we see more and more are those topologies. So this is not meant to be as a detailed network graph of the internet. This is more the concept, the topology, how things work. Like think of Facebook, for example. Like all your friends are there, it's a social network, you want to connect to it. What you have to do, you have to always send your data through the big operator in the middle where everything is centralized. So of course they have multiple servers, maybe even spread all over the world, but conceptually it's one company and one big cluster of servers and data centers where all the data is stored, where all the traffic is routed through. So this makes it especially easy for adversaries or for marketing companies or for secret services like the NSA to tap into all that data. Because in the middle, all the data, all the connections, everything that you want to have is there, and it's really easy for the NSA to get it. It's like you have all your eggs in one basket. So once your basket is compromised, you lose all your eggs. But this topology has also other problems, because it's not only easier to get to all your data and to get to the data of everybody, because the problem is everybody has to use that, so everybody's data is in the middle. So the society as a whole is compromised at the same time, which is dangerous. Like I prefer to have a balance of power to make it not so easy to get to all the population. The other problem I have with this kind of topology is that the operator in the middle can exert power over you, because they decide what functions, what features the service offers, and they can exclude people from using it. They can censor stuff. The service can go down, it can be bought, or it can have backdoors through the NSA. Like all sorts of stuff, which is not nice, that you don't want, because it's less control for you and for your data. So to improve on that topology, we could build it more like that. So you don't have one central point in the middle where everything is, but you have multiple points where the data of users, of the people, is spread over different instances. So it's a lot harder already to exert control there. Like if one of those operators in the middle of a service like Facebook, like WhatsApp or Gmail decide to throw you out, you can just go somewhere else. But in order for that to work, you need to have connections between all the points. So it doesn't matter whether you're here and your friend is here, because there's a connection between the two, you can still talk to each other. So this is about protocol design, about how the internet works. The way Facebook is designed, you have one website, everybody goes there, or you use an app to connect to the central hub, and everybody just connects to the middle. Does any of you know examples for internet protocols or services that work more like that, in a decentralized fashion? Yeah? Diaspora, for example. Jabber, XMPP. For those who don't know what that is, it is chat over the internet. And something that is maybe even older. XMPP, yes? Jabber? SMTP, yes, so email protocols. And email is usually the example I use because it's easiest to understand for people, because most of us still have an email address somewhere that is not necessarily all Gmail. You might have one from university, you might have one from your employee, and all those people want to have control over their own email systems. Like the university does not, maybe not necessarily have all their users' data at Gmail, but they have autonomous infrastructure and technology that they can use, deploy and control themselves, but still interoperate with everybody else on the world. So this is a lot better model of doing networking and connecting people together, not concentrating everything in one single point. So another model that could also work is that. So there, everything is connected really with everybody, and every single user basically has its own little server where people can store data. But then you might also ask the question, like, why do I need a server anyway? Because in today's world we have more and more devices, but we want to have the same data on. We don't need to get them out of sync. You don't want to have 10 emails here, 5 emails here, and one contact here and the other contact there. It doesn't work. You want everything available to you. But still control. So the utopia is to do that. But since not everybody can run their own servers, because you don't have the knowledge, for example, or the time, or you might be able to do it but not as good as somebody else, this model can also work. So from those two, you can go back and forth, and everybody can decide how much control and work they want to have themselves. There is projects like Freedom Box, for example, or with Raspberry Pis, little inexpensive hardware that anybody can buy, plug at home into the internet access, and have maybe pre-installed, ready-to-use server available already. So with that, you would arrive there, but you kind of still need to maintain your own server. So I would prefer this model, but I understand that it's not for everybody. So you can have little bigger hubs where multiple users are sharing one server. It's entirely possible. It's up to you, like what you want. But what you most likely don't want is the one central thing. So do we know where that text comes from? Security and privacy, free software in the struggle against espionage. Have you seen that before? Neither did I, but it's apparently the motto of this year's conference. So, and this also fits perfectly to what I'm telling you, because with free software we are able to install these servers decentralized with open standard protocols to struggle against the espionage. It's like one necessary condition against that, but of course not a sufficient one. The whole topic is much more complex. I try not to put the whole complexity to you. So the software, Kolab.org, that I'm presenting to you here, is one part of the solution, in my eyes. Because it's a server software that you can relatively easily install on a Raspberry Pi or in a big data center. It doesn't matter. Like it needs very little hardware, but it can also work on very big data centers. And that software covers the most basic use cases that people are already used to, which are email, of course. We're still used to write a lot of emails. We want to have our contacts, preferably with pictures on our phone, but the same ones on our laptops and our desktop computers, and maybe on our second phone as well. Same goes for calendars. We want to share calendars with others. We want to publish calendars to the web, have some private appointments, some public ones, and some ones we share with our wife or girlfriend or whoever. Files is nice, like a file cloud where we could store our files, and when we are at Fisl and we don't have our computer, still access them if we really need them, without them being at Dropbox, the service, for example, where they can potentially read your files. Something else Kolab does is task management. So you can say, every week I have to bring out the garbage, and this thing reminds me then of it. Or even do a little project planning, project management. And little notes. It's also helpful for people. So this is how the email view looks like. You can change most of what you see there. Like, I prefer having a threaded email view where you see which response is to which email, like to mark emails as read or star them so I can see them in red and that I have to look at them later. Here you can see little pictures. If the contact is in your address book and you have a picture, it's shown here. You can do quoting, HTML emails, which I don't like, but it's possible. And of course, searching for emails, having many folders, organizing an email, having mailing lists with server-side filtering, automatically putting the emails that belong to the mailing list in one folder, so not your inbox is cluttered with all the emails. So you can manage your personal information more efficiently, especially when we get more and more and more information all the time, so we need better ways of organizing ourselves. Kolab helps with that. This is the calendar view for one day. You can see the different colored events, so this means they are in different calendar folders that can potentially also come in from other people. And in the bottom left you see that you can enable, disable calendars, create new ones, and also check calendars that belong to other people. This is the week view for a better overview with one appointment like highlighted. You can of course have also reminders that then your mobile phone buzzes when your mother-in-law visits, so you have a good head start to prepare yourself for it. This is agenda view where you see like all the upcoming appointments ordered chronologically. You see directly what's coming up next. And this is a pretty neat feature that I like myself a lot. It is when you want to organize a meeting, you don't know when do people have time. So what Kolab does is it creates, if you enable it, it creates anonymized free busy lists of users. So the software knows when are you busy and when are you not busy. Like you see Homer Simpson is busy at 9 in the morning. So I cannot make an appointment here if I want Homer on board. But here at 10, everybody is free. So I have this, just a little cut. Normally you have like a long list saying all the time, and you say, here is slots where I can schedule the meeting because people are still available. I don't need to go to them first, ask them individually, and try to prevent the conflicts. And you can also invite them. I get an email, I can click accept and get the appointment directly in the calendar, and get it updated when something changes, like the place of the meeting. So you can manage events without necessarily going via Facebook. This is the address book view with pictures, and you can have birthdays, personal work addresses, everything that is also in the vCard standards. And you can export that, you can import that, and of course also synchronize it to Android and iPhones, Blackberries, whatever you like. So this is the task management I spoke about, where you can also hierarchically organize your tasks. You can see how much is the completion status. You can share all these with other people on the same server as well. So they see, okay, this project is like 50% completed. There's a subtask that belongs to me that I have to take care of. You can tag the tasks, and you have here little bubbles up here that show you, okay, here is all the flagged tasks. Here is the tasks that are coming up in the next 7 days. Here are already the completed ones. So like really quickly you can change a lot of views to get a best overview about all the upcoming tasks that you have. This is the web view of the file management. So you can either use that and upload files over the web browser, but you can also mount your file store locally on a computer and use it as if it is a local folder. Just copy stuff into there, it will automatically get uploaded and show up there. And on the left you see there is audio, video, images, and documents. And all those types you can also see and sometimes edit in the browser. So this is a view of an image. We have somebody from Blender here, you might like that. You can watch videos in the browser, you can listen to the music, and you can even open and edit text documents and code online with syntax highlighting. This is the settings panel. You can see you have like a whole lot of different settings, like changing a password, different email identities, like when you have multiple email addresses, you can all manage them from this one interface. You can still collect from different email addresses all emails in one server and respond with your work address, your university address, your private address. And of course manage also the server-side filters, which are a great tool. So that's something that we did very recently, and this is instant messaging over XMPP or Jabber chat directly in the web interface as well. You can of course always do that without the web interface, but this is pretty neat for people who just want to click and have things working. So you have your contact list directly there, you can click on people, chat with them, basically a Gmail replacement all in all. And since it's a server and it needs to be administrated, we have a small web interface that makes this easier. So you want to create new users or new groups, or you want to have a second domain for your server, you can all do that via that web interface. Like different roles means like people have more rights than others, if you like. You can have shared folders that are available to everybody, which is also neat for mailing lists. If like you are a small company and everybody reads the same mailing list, you can just make them available as shared folders, so people don't need to subscribe individually. So the emails are just on the server once. Resources is something I haven't mentioned yet. That is, if you are, for example, association and you have meeting rooms and there's people coming in for those rooms all the time and want to book them, and you need to manage this somehow. So you can have resources like meeting room 1, meeting room 2, and you can book those resources and they're blocked for that time frame. When somebody else comes, he cannot book the resources here, but he has to go to the next available slot. And that's also possible. But as I said, native offline clients are available as well. So people who don't like web interfaces can do everything natively. This is for people who still don't use Software Libre that much. Microsoft Outlook, it works via connectors. There is several of them that you can use, and all the OS X applications also work via CarDAV, CardDAV, and WebDAV standards, and of course IMAP, SMTP, the email things. This is more Software Libre. Thunderbird works pretty well for the calendars and the contacts. You need usually 2 extensions. The one is the Lightning to have calendars in Thunderbird, and then you can use CalDAV to synchronize all the events from different calendars. And there is Sogo address book connector for CardDAV, so you get all the contacts also in CardDAV, in Thunderbird to see. But since Thunderbird is not really developed any further, this is what I personally use. It's Contact from the KDE project, who also had a presentation here earlier. And it's a full-fledged native clients for all the Kolab features. This is 100% Software Libre and is continued in continued development, so it's getting better all the time. And for power users with complex setups, like this is really great because it has like thousands of features. I'm always surprised then I find a new feature that I haven't seen before in there, even though I'm using that for many years already. But I still find new features that I said, wow, it can do that as well? So if you don't mind a lot of settings and you're a power user, I can really recommend that, especially if you need to be productive offline, which I often am. I'm in a plane and I need to check some email. It's not here because it's only on the web server. I can of course not use the web client, but with that it caches all the emails locally, so I have them available. And can even respond and reply, and they are sent out when I have connectivity back again. This is the calendar version of the native client. You see I have quite a few calendars there on the left. All day events up on the top. This is a week view where you can see, okay, what's going on in the coming week. That's the address book with built-in QR codes. So if you want to get the contact quickly on somebody's phone, just scan the code and you got it. And of course, if you change a picture here of somebody else, it will be changed on the server and the web client, and then it will also be changed on all your phones and other devices that you connect to the server. So the data stays in sync over all different devices. So if you want to run that yourself, then at the moment you have those options of GNU Linux distributions to use. So how software development works, you have somebody has to develop the software, but then with most free software operating systems, the software needs to be packaged, so you have an easy way of installing it. And most distributions have different things, so it needs to be packaged differently for every single distribution. We use open build service for that. So we host that software on our own server, and we can just have the package sources, and the build server spits out packages for all the different operating systems. So on Debian, for example, you would include the package repository in your configuration, and then just say apt-get install Kolab. Then all the Kolab packages get installed, and then you have to say setup -Kolab, hit enter, and follow some instructions. This is because Kolab uses as much available software livre that it can, so we don't want to invent the wheel from scratch again. So of course we use whatever is available, but this needs to be configured properly to work together in a proper way. That's why you need to run that setup utility after you install stuff. Like some of these packages are better maintained than others. Like Ubuntu, we currently lack maintainers. So if any of you is in Ubuntu packaging, like would be really happy if somebody helps out more. And the Ubuntu, the Gen 2 packages, the e-builds, are also not really officially on our server, but a community effort by some other guys that have that on their own repository. So this is like the high-level overview of how you can imagine this to work. Like in the middle, you have the Kolab groupware. It can be like in 1 or 2 data centers, and it synchronizes and connects all your devices over as much open standards as possible. Like, how many of you are interested in a more detailed look into how Kolab works? Okay, this is like most people. Because I saw there's many technical talks on the agenda, so I also prepared to be a little more technical and not just to be so high level, we have those features. So for those people, there is this slide. Okay, people are happy about that. So let me explain. The central thing and the central principle of how Kolab works is it uses IMAP exclusively as a NoSQL storage engine. Because the great thing with IMAP is it's a robust protocol, it's an open standard, it's widely implemented, and you get all the synchronization work that needs to be done for free, because it's already there. Most solutions only use IMAP for email, but there is extensions to the IMAP protocol which allow you to store arbitrary objects in IMAP. And that's what Kolab does for all the other data, which is not email as well. So the heart of every Kolab installation is an IMAP server. Like we mostly use Cyrus, but Dovecot is also possible. Below the IMAP server is LDAP, which is like a user directory database. If you have just yourself on the server, it's not really so much helpful. But just imagine you have a server for your association or your company, and you want to have hundreds of users on there. Then it's helpful to manage them via LDAP, because it also enables them to use the same credentials to log into the Kolab server, but maybe also in other servers. And we have a central user directory which is also synchronized across all the other services you might offer as well. And there we prefer the 389 directory server, which is like part of Red Hat, but OpenLDAP or others are working just as well. And then for sending emails, of course, you need a mail transfer agent that is here. And there we actually always use postfix. And here a little bar on the side is Wallace. This is a little daemon that runs on the server and that postfix can query for certain things. And it's written in Python and it's modular and you can do crazy stuff with it. You don't have to, but you can. Like, for example, putting a footer under every message that is sent out, for example, or translating incoming messages automatically in and appending the original message to the message before, or doing crazy things with messages that you don't want. But it's also necessary for the resources I mentioned earlier, because there is certain emails are being sent for inviting resources, meaning I need to book the meeting room. Then this little guy says, oh no, the meeting room is not available, and rejects the request automatically without user interaction. And below that, there's of course virus and spam checking, because you don't want to have all that spam and you don't want the virus in your inbox. And there we use Amavis, ClamAV, Spam Assassin, which are also mostly the standard tools that people who administer servers already know. So how does it work when you, for example, log into the web client and want to check your email? So then you come from up here, from the very top there, and you make a connection to this web server, either Apache or Nginx. And underneath there is the Roundcube framework on our web client. I don't know, how many of you know Roundcube? 1, 2, 3, 4, 5 people. Yeah, so that's what we integrate in our web client. And since you know that, you have probably seen that the web client uses that because it looks very similar. So you're hitting this Roundcube framework here, and with your username and password that you entered, the web client logs into the IMAP server and accesses the data you request and feeds it back to you and shows you your emails. Like this is another advantage of using IMAP, is that even if your web server is compromised by somebody, like an attacker who got into your server, he can still not easily get your emails, because he needs still the username and the password to access it if he's just sitting on your web server over there. If you have all the data in a database, the web server has one username and password to access the database, and then there is all data, then the attacker can just copy all data in one go. But because of the IMAP topology, he has to wait for somebody to send actually the username and password. And since an attacker usually doesn't sit there forever waiting for everything, but because he is detected at some point, it gives you like a higher level of security, but of course not absolute security, because there's never such thing as absolute security. It's always the process and the question of how good you secure other attack vectors as well. So another example is if you have your mobile phone and it connects via CardDAV and wants to synchronize your address book. Then you also come from, oops, now we're back to the web client. It comes from up here and also connects against the web server and against the Roundcube framework, which has the adapters, you could say, for all those various open standards protocol available. And they all then connect back to the same IMAP database. And to speed things up, because sometimes it can be slow if you have many calendars and you are just interested in the ones for today, it might make sense to enable here a cache which just makes the lookups faster. If you just want to see the events from today, you're not interested in all the different events that you had 10 years ago. So the caching layer makes things faster. And if you have a native client like Contact, or for email then the Kmail component, then you would not even come from up there to connect through the web service. You would directly connect to IMAP here to the site, to the web server. And when you send an email, it's also not done through web servers, but you directly go to the SMTP and talk to postfix to send emails. So what else is there is the Kolab daemon, which is responsible for interconnecting all those services. For example, you create a user in your LDAP directory. What you want then is that in Cyrus, the mailboxes are created automatically. The same case when you delete users or change their names. Like you want to have all these things synchronized internally. And that's what the Kolab daemon is for. He also provides an API where you can hook into other systems to interact with Kolab. And there is a command line shell where you can say Kolab help, and then you can say Kolab list mailboxes, Kolab move mailbox, or list users, create shared folder, like all sorts of commands if you don't like web interfaces. Okay. The web administration panel is, is also attached here to the API. So if you manage your users through the web interface, you come from up here. Is there anything unclear or any questions about that before I continue? Yeah. Why? Yes. All the data is stored in IMAP. Just for caching. Another advantage of that is that there is really easy tools, like if you have to migrate from one server to another, you just need to sync over your IMAP database, and that's it. So then you have everything on your new server. So it makes migrations a lot more easier. What do you mean with application data in that context?
If it is the configuration for IMAP and Roundcube, or just the user data like calendars and contacts?
Part. The goal is to have all the application data as well available in IMAP as like configuration objects. So when you go to another computer, your whole configuration, the color of your folders, for example, your identities are still the same. But that's a work in progress, to be honest. Like this is the goal, but it's not yet the case. For some stuff, yes, but not for everything.
When I installed Kolab 6 months ago, I think, there is a database, SQL database, created to control the access control list, ACL. It's changed. It's in the IMAP server, or there is a database to access control list?
It's in the IMAP server, and that's yet another advantage of using IMAP, is because it gives you the ACLs, the access control lists that define which user can read what folder, or can write into what folder, or which user can delete emails from which folder, is all just given for free by the IMAP server. But let's take this as the last question and then do the rest at the end, okay?
If you have another server, like if you have a server running Kolab and I install Kolab 2, the two servers can communicate. So if I create a appointment in my calendar, you can see it and make an appointment with me, a meeting.
Yes, the way that works is if I want to make an appointment with you and you're on another server, you are in my address book, of course. And when I say new event and I say participants, I can say I want you as well, and then it's auto-completion, and you get you with your little face, say yes, I want you, and then you say create the event. And then it says, do you want to invite all the participants? And I say yes. And then you get an email where you can accept, decline, or counter-propose something. And if you accept it, you have it in your calendar. What does not work is that I share my calendar on my server with yours. Because for that we would need a more sophisticated federation protocol and still have all the security benefits of having a closed down IMAP database. Because if I do that, then the web server again would have access to all the data, which we want to prevent. Okay, but I heard like here's people who have already used Kolab 6 years ago, so I would like to tell you a little bit about the history of where Kolab actually comes from, because software like that normally just grows on trees, like somebody has to write it. And in this case, it comes from a German government agency, which didn't develop it itself, but it made a tender and said, we need something like that. Like we have all Microsoft Exchange, and we need to exchange. Because we cannot rely on the US to provide our sensitive software and our data. There's potentially backdoors. It's no open standard, so they control the protocols. They say what goes in and what goes out, and they can change it at any time. And we don't have any power. And we just have to pay the high costs every time. So they said we need an own solution. And at that time, it was quite visionary that they said we need that solution also to be software libre. So the tender was in 2001, so that's more than 13 years ago, it's quite old. And then a consortium of little or middle-sized German companies got together in that consortium and just developed the software, and all those companies already know and understood software libre, so they were using as much as components as they could, and actually thought about, okay, if we want to do that right, how do we do it? And that resulted in the architecture I showed you before, which actually won a prize as well for the design of the system. So then there was, 2 years later after the tender, there was the first version, Kolab 1. 2 years later, Kolab 2. And that found wide deployment, like people all over the world were using that. But since it was just projects or tenders by one government agency, which one had the solution, was not interesting in developing further, the development kind of stalled a little and slowed down, and people thought, okay, how can we kickstart it again? And the companies that were involved in making Kolab, they did project work. So they did one project, completed it, and next project. Like they didn't do product development where they have one product and making it better continuously, supporting it, and making sure that everybody has something nice in the long term as well. So the company said, we found another company which is called Kolab Systems, just founded like 4 years ago, which then took over Kolab development and like kickstarted it again, and started by identifying all the parts which were not good anymore, which had to change, and then came up with Kolab 3 1 year ago, basically. So the restart of the whole thing is quite new. It's 1 year ago, but now we have a really nice, modern, solid base with cool web interface and supporting all the protocols we need to actually replace Gmail or Microsoft Exchange already today. Like it was possible before, but now we made the leap into the new century, basically. So let's talk about the business side of things a little bit as well, because I've heard that many people are also critical. Okay, that's free software, but then there is also this company behind it, and like in the past I was the same, but now I see that there is a lot of tasks where it helps a lot to have paid developers working on them. Because in free software projects where people do that in their spare time, they just do stuff what is fun. Yeah, but in software development there is also parts which are not fun, like documentation, for example. Like after the job is done and the thing works, what do you want to have? Like, why document it afterwards? Boring. Or making this little QA afterwards to make sure it works for everybody. Or making the interface then more appealing for a wider audience. Because normally it works for me, so fine, I stop here. But it helps then to have professionals that you can pay and tell, well, your job is today to make this and this better. And for software that is reliable, it's extremely important. So, but what you still want the freedom that software libre gives you. And since this is like different dimensions or axes that can be easily confused, I made this little diagram where you have 3 axes and 3 factors. One is control. How much control do we exert over the software? Like, is it all software libre or just parts of it? And where does the revenue come from, which is the business model? And how does the development model look like? So how much collaboration is there? Do you just do it yourself? Or do you let others participate? And ideally, you have a business model that allows for, you have a development model that allows for a lot of collaboration, including many people, many interests, like making the software so that everybody benefits in the way they want to benefit, and exerting as less control as possible, ideally none, by making everything software libre. And the way the business model then is then a different question. That is then up to you. We see a lot of companies that use a business model which is tightly related to the control they exert. Like Microsoft has total control and very little collaboration. But have a business model that relies on the control, which is always then a problem when somebody else comes and gives you something which works equally well but controls you less. Because you don't want to be controlled, you want to have freedom. For example, because people force you to pay high prices, but you don't want to. But if you're stuck on their solution and it's proprietary, you can do nothing else. With free software, you can just go to your local company next door, if they have the expertise, of course, and tell them, I want you to do it. Or ask, who can do it cheaper? If there's a free market and you have to differentiate on how good you are and not on how much you locked in your users. There's also like many like open source companies that say, like, we are open source, but what they then do is they still have certain degree of control, or they ship a version of their software which has all those nice features, but it's only for their paying enterprise customers. And the community then gets like what's left there with some features. And that's also not nice, because this is what I call neo-proprietary business models. Because they use the open thing for their marketing, but still close you in by exerting control over the software, because the strategic important parts are not free. So what is a free software company? Is that a company that just uses some free software? That doesn't make so much sense, because right now we have software libre in the mainstream. Everybody uses free software. Every company uses free software. So that cannot be the criteria. Contributing little to free software is also not nice. So when I talk about free software company, I mean a company where those revenue streams, so the money that comes in, does not belong on any proprietary products, but they give the software free also to their downstream users and to all their customers. And that's what Kolab Systems is. So Kolab Systems, I put Red Hat below because the business model of Kolab Systems was like a lot inspired by Red Hat and what they do. Like they give their software to their customers as free software, and that has the effect that there is something like CentOS, which takes exactly the same thing and puts it out there, and everybody can use it still for free. But what they of course don't get is the quickly security updates by Red Hat, and they don't get support if they have a problem. There's nobody they can call except maybe the company next door. So Red Hat says, okay, we're competing with everybody, but we're still getting customers because we're good and we know what we're doing. And that's exactly what we do for Kolab. So we offer service level agreements for large companies or for small organizations or whoever wants to. It's like a product. You can use the software for free, but there's also a service level agreement. And what we also do is, like Red Hat, we offer a software subscription where you can directly get from us the quality assured stable software, which is not like the latest development branch where the new feature has just been merged in and you might run into trouble. So if you need stability and you need long-term support, you want to know in 5 years, I can still use that software, I'm not forced to upgrade, then this is why people choose the software subscription. Something else is hosting. So we found out that many people would like to use the free software and would like to support us somehow, but they had just not the skills or the time or the will to install the server themselves, host the email server, tweak their own spam settings and all things like that, or fix things when they break, which in computing they sometimes do. So that's why we offer hosting, where you can just go to the website, say I want this account, sign up, And then you pay for the service that we offer there. So there you're not the product, but the customer. And with Gmail, it's all free, and they crawl your data, sell your data, show you advertisements, and finance the service this way. We decide, for people who like free software, they can just do that. If you're interested, you can check it out. If you like it and want to have an account, I can also hook you up with a special Fisl discount. Okay, there is consulting. Like sometimes there is big companies saying, oh, we have 100,000 users, but it's like much more complicated the setup, so we need your help. And what I haven't mentioned is that all the functional components in the architecture, you can scale them horizontally, like as much as you like, as well up as well as down again. So in these cloudy, elastic scenarios where there's a lot of users coming now, so you need to make your service faster and bigger quickly, but then they go away and you need to go smaller. All that works with Kolab as well, but it's of course more tricky, and that's where we sell consulting. Custom development is also very nice because somebody comes to us and says, we want this feature. So we have paid programmers that we set on the problem. 1 week it's done, and we can release it as free software again to the upstream, so all other users benefit from that, and somebody paid just once. I really like this synergy effects where free software development is funded and the result benefits the general public, so everybody who uses the software. And training is another aspect because you have it in your company, your administrators don't know everything, so we offer training and tell them how things work. Very quickly, one of the European customers that use Kolab, this is the Basel, Switzerland, and there all the public schools use Kolab for their children. So then when they go to school first day, they already have a Kolab account. And the servers are hosted by the school administration themselves. Another example, recently in the news, this is Munich, München, Europeans like lighthouse city for software livre adoption. So they have 40,000 desktops for their administrative workers, and they are all software livre, and they are now starting to use Kolab with the native desktop clients based on Contact. So this is like the quick summary. What to remember, it's like basically a groupware solution, that's what it's called. It's 100% free software, also the software subscription, what customers get. It follows open standards as much as possible, all the way down to the storage layer. Like everything has RFCs and open standards for how they store data. It's a secure, scalable architecture, and it can run on your Raspberry Pi or your big server cluster. And what helps stability and feature improvements is that there's also commercial backing, but done in a nice and ethical way. So if you're curious about that and want to interact with other people when you have problems or you want to help others, we have a Portuguese user list, mailing list, where you can subscribe and send an email there and say, hey, I installed, I have a problem, can you help me? So this is where the Portuguese community comes together. Of course, also have IRC channels and stuff like that where people talk English, but for Portuguese language, this is a dedicated list. You also find that on kolab.org. So, end of my talk. I'm Thorsten Grote, Thorsten@kolab.org. The company is Kolab Systems, and the email hosting or groupware hosting is mykolab.com. So, muito obrigado. And now we have a little time for some questions, right? Okay, we have one up there in the middle.
Two questions. Kolab, there is a backup routine of my accounts, and the data of my account I can migrate to another storage with 30 days, 2 months. There is a feature for that.
Sorry, can you try to repeat the essence of your question again? I didn't understand.
Okay, there is a backup routine.
Backup?
Yes.
Yes, basically, and then to migrate it to other servers as well?
Yes, can I migrate that account, the data of my account, 2 months old, for example?
So you have different possibilities there. So first, since it's all using standard solutions and available software, you can use all the available backup solutions that are there already. Something else what you can do is you can use offline IMAP utility to make snapshots of certain stages of your IMAP account. And then go back to those stages as well if you like. Or you can individually restore certain messages that you lost or accidentally deleted. That's possible. But you also said something about transferring to other accounts. Then with IMAP, you can just sync all the IMAP data to another IMAP account. That's easily possible.
Hi. So first of all, thanks for the talk. It was an amazing talk. I didn't know Kolab. For me, it's an awesome project. And one of the things that I was thinking about, in the beginning of your talk, you talked about the topologies that you wanted to do. And you say that now you have something that is more decentralized, but still have someone centralizing the information. And the goal was to have something kind of totally decentralized, like peer-to-peer thing. So I was wondering if you have some idea now for reaching this goal, like having totally decentralized, because having, for me at least, I think it's a sensible thing to hold personal information. Like it's not something as simple as BitTorrent, like you're sharing a file that everyone is sharing the same file, or Tor that you're sharing just the internet traffic. So you have personal information, and these nodes that will get this information will have access to this also. Like it will be. Like, what kind of thing you're using to hide this information, like to encrypt this information for the node don't have access to it?
So what is a bigger node here is basically a server. And if somebody has access to the server, they usually have access to the information as well. Just because the information is there. Even if you do hard drive encryption, if the server is running and people have access to the server, they can see what it is. What you can do for email, at least, is you can use end-to-end encryption, PGP. Like here were some crypto parties where people were shown how to do that. That works. You can do that, and we recommend that because everything what you do server-side encryption, the server can usually also decrypt again. So that doesn't help. And you were concerned about how to get from this model to this one, yes? This you could do if everybody has their little Kolab server at home. You can do that. And since it's all software livre, you could also start a company tomorrow which sells these little boxes that have Kolab pre-installed and have some automatic updates which never break and that make everything really easy for people. They just take that thing home, plug it in, and maybe do some, I don't know, get an own domain which you also offer them. So they have their myname.com.br. You can do that, and then you can get closer to that model. But it's, of course, really hard because you have to ensure that things don't break. Like if you sell people those boxes, the upgrades have to be super smooth, and nothing should go wrong. So that's why we are still mostly at that model where you have more people on one server, so you just have to work once to administer the server, but still serve a lot more people. But here, at least with this model, with decentralized protocols, you can choose which operator you trust. Like in a non-standard way, like Facebook works, you cannot choose. If I want to talk to Facebook people, I have to be at Facebook, no choice. But here, you can make your own server, like this one, for example. Okay. Here, this one has its own server and is directly connected to the others. So it's not at one of the bigger points. Unfortunately, the time is now up, but I am here the whole day, and you can talk to me directly if you have questions, or send me an email to torsten@kolab.org. Thanks again for your attention, and see you later at the conference.